So the serverless architecture is really just another implementation of cloud. And I'm not a specialist by any stretch in serverless architecture. I've not heard of this before until right before I attended the conference. But I do have some technical background. Started out in electronics, worked my way into telecom. I kind of started in that field before they called it telecom. And then back around 1987, I discovered my real calling was what I felt like was teaching. So while working at Texas Instruments, started teaching part-time, eventually started teaching part-time for Collin, and then turned my part-time job into a full-time job back in '99. TI started selling off pieces of the division that I was in, and I didn't like who they sold to, so I figured here's a good chance to jump ship. I also did a little bit of the logistical support as discipline lead for our program and managed some of our Cisco labs. And again, the reason I'm here is because our business industry leadership team mentioned that we might want to look into serverless architecture as some content for a course, either add it to a course or create one. So Dr. Mahila asked me to attend this conference. So I went down there, having no clue. I had some idea, a guess at what it was about. And it's another application of cloud. So looking around the room, a lot of us have been around for the evolution of computing. We went through every phase of it, from the mainframe world to kind of where we've gotten to now in the world of, y'all remember that thing? I wasn't there, somebody may have been there. I wasn't there at this one. But I do remember some of this stuff. I remember my first electronic calculator. I was a private in the military, and it cost me about 1 month's salary to buy that thing. So we've made quite a progression. But where we're going to now is we started connecting our computers together. The client-server world, mainframe world, and then come to virtualization, right? We want the hardware out of the way, so to speak. So we started virtualizing. Once we started virtualizing, we discovered, do we even need the server locally? I said, no. We don't even have to have the server locally because we can push this stuff out into the cloud. And obviously we still have our issues there with the cloud. Since I'm old school, I'm a little bit more skeptical about putting all my data and my applications and just trusting somebody else with everything that I've created, so to speak. But we're going there. So now our services are out there. So we not only hosted our websites, but putting our services out there. And that's kind of where this serverless architecture takes us. It's another implementation, another place, application for those cloud services. So they take it from the point of just having your stuff hosted, so to speak, like a website hosted, to actually practically everything out in that cloud. And they kind of put this into 3 different things. Your infrastructure as a service, where you can say, I need so much computing power, I want to use certain operating systems, and I want my applications to run all out there. So practically your whole network. Now obviously you're not going to be able to get rid of all your network locally because you're going to have something sitting in front of, right? Your laptop, your smart device, whatever that case is. You've got to have some internet connection where you are, so you're not going to be able to push all your hardware support out into the cloud. But in a small business place, you can push most of it out there. Now there's some, we'll talk later, there's some large companies that are using this too. Now they kind of stack these things up. So you have your infrastructure first, right? Kind of that's your foundation. And then your platform, and that's when you're going to say, what op systems am I going to run, so to speak. You got your hardware, how much memory, how much storage space do I need? And then finally, kind of at the top of the heap, and that's kind of where the serverless architecture, the conference that I went to, that's what they were mainly focusing on, was the applications running out in the cloud. They didn't spend a whole lot of time about the platform and about the infrastructure. This conference was mainly for the developers, but they did touch on some of everything. So just quick definitions here. Cloud computing, your infrastructure, right? Just in other words, take your hardware, hand it over to your service provider. That's what they've done there. Platform. Now there's more here than just operating systems, but you kind of get the idea of what that's about. You can have public cloud, private cloud. You've got to decide how you want everything implemented. Some stuff you may push out into a public cloud, but there's going to be some stuff that you're going to keep in that private cloud where you, maybe your clients, some of your business partners can get to that part of the world, and that public cloud can be whatever you want it to be. And this is what most of the conference I went to was focused on. software as a service. Now, there's pros and cons to any of this stuff. This concept of what they're calling the serverless architecture, they're saying it kind of got a hold 5 or 6 years ago and started getting implemented, and I'm not exactly sure where it's going to go, but at this point it's not showing any signs of slowing down. So we'll see how far it goes. I guess if we were to look back at technology we've seen develop and wonder, is this going to go anywhere? And now we look back and say, how do we live without it? Right? Most of us have 1 or 2 in our pocket or laying on the desk of things that we weren't sure if they were going to work. Now, the concept is use services to do everything you can. And some of the beauty of it is it's on demand. So I don't have to have a server sitting in my house running 24/7, using up electricity, air conditioning, and sitting there idle, so to speak, that I'm paying for. And then I'm going to have bandwidth. Whoever's going to be the user, think about a web page. It's a simple application here. I've got to have bandwidth for my customers to reach into that web page. I'm paying for that bandwidth. Right? Not here. If I put that service out in the cloud, they're not coming through my infrastructure to get to my web page. And I only pay when somebody reaches in or runs an applications or access something. That's when they talk about the execute the code on demand. The beauty of it is you make if you're a developer, you make your applications as simple as possible. They do one thing, they do it well. And then you can, now back when I was going through programming, we call it modular code. I built pieces, subroutines, and then we could build these things to be very general. Then we could say, okay, I need a new program to do something. I just put together a whole bunch of these subroutines and build a new type of interface, done. Similar concept, a little bit more advanced, similar concept of what they're doing now. They're just changing the names to protect the guilty, I believe. Again, third-party services is key things, but it's just kind of a quick graphic of how that interface would work. So your user, whoever that is, they may be inside of your organization, they could be a customer out on the web, who knows, they initiate some action. But instead of coming through your infrastructure, they reach right to your provider. Another beautiful thing is the scalability, automatic scaling. I don't have to go, oh look, my server's getting inundated, therefore I've got to put more server services here, at least temporarily, to provide for whatever kind of customer hits I'm getting here. Automatic scalability. I don't worry about it. 10,000 people hit it at one time, not a problem. That's my service provider's issue to make sure that my customers are getting what they need. Real handy. One of the examples they used here was I can't remember, a province in Australia wanted to do some kind of poll. And they were going to do this after election day, so they had all their citizens say, hey, go home and do this poll. Well, they found out they paid millions of dollars to have somebody, a company, build the infrastructure, write the code, the whole shoot match to do this. If I just lose my right there, I'll just talk louder. Several $1 million. They didn't expect everybody to actually do it. Lo and behold, their citizens listened, and they actually went home after election day and got on that poll, and it crashed. Case studies of students in a course related to serverless infrastructure, they took that on themselves and said, can we have done this? So for $200, they built software to do this and got the web services and tested it. No problem. It worked because automatic scalability. It doesn't matter when the people hit it. So had that concept been, had the people who hired that original multi-million-dollar company been aware of serverless architecture, they might have hired a couple of students for a few $100 to do the same thing. So it does have its place. Now, is it perfect? No, it's not going to be perfect. Now, another thing that took me a little while to get hold to is that vendor-specific. A lot of the services, you might write code in a given language that's universal or standardized, but the interfacing of your code to whoever you chooses a vendor, that's vendor-specific. Now, that's one of the cons. That means your code gets kind of locked in. If you decide to move vendors, you got to go rewrite some stuff. So that's kind of a little bit of a challenge. Now, the big one right now, Amazon services, Amazon Web Services, they're the biggest one out there. But the competition is gaining ground quickly. There are several others that are in this market. IBM has their web services. This is some of IBM's icons they use for some of their topologies. And to me, I'm looking at this, and then I look at this, and I'll see no correlation. But It's the same basic function, just different ways of implementing the same function. I'm a car person, so I quite often use car analogies. If you go out in that parking lot, you're going to see a whole bunch of automobiles. They are similar, but they are also vastly different. Right? You'll see everything out there from a Kia Rio to an upscale Mercedes. They do the same basic thing. Get you from point A to B. Right? No different here. Now here's probably four of the big ones. Amazon Web Services, I mentioned, IBM, Windows. The Windows one was the one that was most interesting to me, to find out what op systems they're using on their web services. And a lot of it ain't Windows. Go figure. And the four major companies that I went and looked at, they all have where you can go set up a free account and play with this for free, just to get an idea of what it can do for you. Again, from the development perspective. And there's Microsoft has their Azure service. So again, and there's more than these out there. These are just the big ones that most everybody's familiar with these, with the names of these things. Each one is going to tell you why theirs is good and why theirs is bad. In my opinion, the advantage, if I want to know what's wrong with the Ford, I go ask the Chevy dealer. If I want to know what's wrong with the Chevy, I'll ask the Ford. Because they can tell you what they believe is the good parts. They just don't tell you what necessarily is the bad parts of each one of theirs. They're all providing the same basic services. So they'll each one have their little tweaks on it. The pricing is almost equal, right, for each one. Now, not only are there the companies providing the services, but now there's a huge market out there for companies providing support services for your serverless architecture, such as monitoring. That's what IO Pipe is doing, monitoring statistics. They can kind of tell you, when is my app getting hit? I'm going to get a bill from whoever my service provider is, but how do I know when my app's getting hits and where the hits are coming from? So I can focus my marketing if that's what the kind of thing I'm doing. Each one slightly different for what they can do. So there's a myriad. I met a couple of folks at this at the conference, a couple of the speakers that had started up businesses in the last 5 years doing support services. Fairly young folks, from my perspective anyway, late 20s, early 30s. They're now semi-retired, got their multi-millions already. Now they're continuing to work, continuing to develop, but they hit the market at the right time. They were developers. Matter of fact, one of the companies, this company here, it comes back up, what they decided to do, they're actually providing online training specifically for AWS Lambda to train you in how to write the code and develop your serverless architecture. And they offer the training for the certifications. And their company's totally serverless. They started out writing code. One of the gentlemen was writing code for Microsoft in the web services world. So they saw this market and said, hey, you know what, nobody else is here yet, why don't we be one of the first? So already got a huge training. They have about 250,000 students or so worldwide. Here's a few of the companies that are pushing to use serverless architecture. Of course, the first one's a pretty big one. The bottom one, the iRobot, we know them as a robotic vacuum cleaner, but I didn't realize what all they do. So now what they're doing with the serverless is they're collecting data from their vacuum cleaners. I never thought about that being an invasion of privacy. The vacuum cleaner that's running around my house is collecting information. Okay, what kind of information do they want from the vacuum cleaner? Okay, what kind of junk, what's on my floor? Yeah. And then green too, that was interesting also. These folks are based in Israel, and they're using serverless architecture to help automate and optimize trash collection. So instead of the typical thing where the truck goes out on a given schedule and sometimes it comes back half empty, sometimes it don't, they know how many trucks they've got to send out based on how they're doing this. They're putting sensors in cans and in trucks, so they know how many trucks they need to send on a certain route. They can actually alter the route so they want that truck full when it gets back, not half full. More efficient. Right? And I don't know what the drivers think about that when they get home and say, hey, we don't need you today. I don't know if there'll be a union issue with that or not. Now, so the pros and cons, right? Reduced operational costs, that's the big one. And this doesn't matter, I don't care if you're talking about infrastructure, platforms, your software, whatever the case may be, you are going to reduce some of that cost. Greener computing, I never realized that servers have a carbon footprint. I've never thought about a computer being a polluting device, but they do. Now, the cons, I mentioned that first one, this is a big one, vendor lock-in. At this point, this is not standardized. So once you choose a service provider, a chunk of your code is unique to them. So if you decide to move providers, you got to go back and do some more work. Now, I'm assuming that if this catches on and really goes, they're going to start standardizing a lot of this. But again, that's something that we'll see. And of course, another concern, again, I'm old school, is that third item there, security. Everything's out there now. I'm trusting somebody else to support my service. They've got my code. They've got my data. It's all out there in the cloud. Some people probably that are born into this world, so to speak, may have no problem with that. I still do. And I can't say that I can justify my concern. It's just because I'm old school. I don't know if that's going to go away or not. And that, folks, is kind of, I'm going to call it my lunar orbit overview of what serverless architecture is all about. I think my time is like 3 minutes past due. Actually, I have 20 seconds. No, I'm just making it. Thank y'all for your time.